Not only you can, you probably should. All right, so we are going to go ahead and take a look at these. Starting with this first one, this was out of section 5.1. These problems on the test, when you have the test on Monday, they give people all kinds of fits. So if you have not looked at the problems in 5.1, maybe you're waiting for an invitation, let me invite you to work the problems in section 5.1. Okay? There are some real beasts in there if you go in there and look at them. And if you have not looked at them, they'll be new to you when you see it. Okay? Towards the middle to end of that section 5.1, it gets nasty. All right? And some of you right now have no idea how bad it can get. Okay? I mean, I don't know any way to say it. It just gets nasty. -3 to the -3. We're not going to make that 9. A lot of people go -3 times -3 make that 9. We're not going to do that. X, -2 times -3 is +6. Y to the -3 over Z to the -12. Now, what's the rule about negative exponents? You can't have any negative exponents, right? So anything on top has to move to the bottom. Anything on bottom would have to move to the top. Now, that's only if they're negative, right? So as we look at this, -3 to the -3, that needs to go to the bottom. Nope. That's going to be -3 to the third power. We'll deal with that in a second. How about the x to the 6? Do we need to move that? No, that's where it stays where it is, right? So x to the 6 will stay on top. How about y to the -3? Do we need to move that? That needs to go to the bottom as well, right? Okay. And the z, do we need to move it? That needs to move up. So z to the 12th power on top. Now, we'll finalize this. What do we get? X to the 6, z to the 12th, y to the 3rd. -3 raised to the 3rd power is -3 times -3 times -3, which is -27. Wait. Say that again, please. Okay. And the question was, when we do what? Well, the answer is because the z is to the -12. But you said something else that was more interesting than that. The question is, why is the z moving? But you said you didn't think it moved because we multiply the -12 by something. What was we were multiplying by? Yep. And if it's negative, you have to move it where? Okay, great question. The question is, if it's negative, I thought it moved to the bottom. And that is, if it's x to the -2, it moves to the bottom. However, if there was a number on the bottom and it was negative, it moves up top. So it's negative on top goes to the bottom, and negative on bottom goes to the top. It's not that they always end up in the bottom. That's where they end up. That's only if they were on top that they end up in the bottom. Okay, so they basically change location to make it positive. Yes. Okay. So the question, just so that everybody can hear it, was if we multiply and we have a negative number on top and we have a negative number on the bottom, the negative number on top will move to the bottom and the negative number on bottom will move to the top. Yes.
And once the number is on the bottom, do we have to have like the negative sign, or is that already automatically implied because it's at the bottom?
No. It went from the top to the bottom, and that changed the sign. Anytime you change the location, you change the sign for the exponents. There was a question back there, yes. Exponents, right.
So it'll be -27, not
precisely. Yes.
Why wouldn't you get the negative 27 on the top when you were doing the other?
Okay. So why wouldn't the negative 27 end up on top? Okay. What makes you think it would end up on top? Is it because it's negative down there?
You're multiplying all the exponent by the output. Why wouldn't you just go ahead and do the 3 and then it would end up on top?
Okay. So that's a very good question. The question is, why don't we, when we do the negative 3 to the negative 3, we just deal with it, call it negative 27, and be done? And the answer is because you, nor I, nor anybody else can take this and raise it to a negative 3 power. You cannot do that. You can take this and raise it to a third power. You cannot raise anything to a negative power. Understand that. 5 to the negative 2, you cannot do. You have to move this first, get it back positive, and then you can do it. You see, 5 to the second means 5 times 5. 5 to the negative second don't mean anything. Like a lot of people go, oh, it does mean something. It means negative 5 times negative 5. I'm like, what the hell is that? And they're like, well, the negative just makes it negative. No, it does not do that at all. The negative makes it move locations. So the negative, only thing it ever serves to do is say, hey, you're not going to be on top. You're going to be on bottom. Or you could have it negative on the bottom, and it would say, hey, move to the top. And now that's back to something you could do 3 times 3 times 3 times 3. So anytime you have a number being raised to a negative power, just know you cannot do that. There's no way to do that. Your calculator won't do it. I mean, I shouldn't say your calculator won't do it. It'll give you a decimal that you probably wouldn't understand. Okay? You got to move the location. All right? Now, the other thing that I see a lot is people from here will want to take the negative 27 and move it to the top. And if I were giving you a multiple choice, I dang sure would put it in there. I'd leave that 27 on top and watch how people put it, because it'd be a common answer. It's not a negative number moves, it's a negative exponent that moves. Very important point to make, to distinguish. Yes. Okay. Questions? Any questions on that? Again, there's this stuff here, and this is all in section 5.1. And again, if you have not done 5.1, the first half of the test tomorrow or on Monday, it's going to be brutal. I mean, you're going to get your name, and you're going to feel real good about that, and then you ain't going to get much more after that. No, you better look at it. Okay, then you're okay then. If you haven't looked at it, it's bad. The problem with doing that is that creates a lot of other issues. Not to say you can't do that. That creates a lot of other issues somewhere else, though. So then I got to go fix that. So it's better just to do it the way we're doing it. But you are right. You could do it that way. Okay. I used to teach that way, and then that was actually worse. So, yeah. Any other questions? Please, again, if you haven't looked at 5.1, please do so. What did you get here? Donald, you got this one? No. Okay, Donald, so give it a shot. What'd you get, Donald? So you did the cube thing there, like the little m thing that we were doing. This is the difference of two squares. That's not that. That's the next one. So this one factors to x squared minus 4x squared plus 4. Stop.
So that's the correct answer?
No. Now, from there, what do you got to do? So now this is the difference of two squares again, and you must continue one more time. X plus 2, x minus 2, x squared plus 4. Now you can stop. Okay? And these problems are straight up cruel sometimes. Okay? because I've seen problems where, say, for example, you have x to the 8th minus 1. That's brutal. Okay, it seems easy enough. It's brutal. Because this is x to the 4th plus 1, x to the 4th minus 1. But then this is the difference of two squares. This is the difference of two squares. So that's x to the 4th plus 1, x squared plus 1, x squared minus 1. But then this is the difference of two squares. And so you'd have to continue again. It's like a pyramid. Okay? So just know that these problems can go, as long as you keep getting difference of squares, you got to keep going.
Is that going to be on the test? Say something.
The question was, is that going to be on the test? The answer is, it's certainly within reason. No. Okay. Yeah, it's very well within reasonable. Yes. No, it's got to be the minus one. You see, the sum of two squares doesn't factor. That's a great question. If I say to you, factor x squared plus 9, that does not factor. This is prime. X squared minus 9, that does factor. That's x plus 3, x minus 3. Yeah. I'm somewhat confused. Shh. You mean if I do x squared plus 4 here, and then x squared minus 4 here, that does not matter now. But you still got to continue with the x squared minus 4. And get x plus 2, x minus 2. Now, if you say x minus 2, x plus 2, it's the same thing. Okay.
So then what about x squared plus 4?
That's prime. You can't do the pluses. You can only do the minuses. Unless they're cubes, and then you can do them. But those are not cubes, so. Pluses you cannot do. Despite how hard you try. Because a lot of people try to do it. You see, the problem, Wanda, is if you try to factor x squared plus 4, you're only, I use this word, I'm going to filter that. What most people would want to do in order to factor x squared plus 4 is to do x plus 2, x plus 2. I mean, that's what most people, when they think of it, was what they would want to do. You do get x squared and you do get 4. That's not the issue. The middle part doesn't cancel because the signs aren't different. So that's why you can't do the pluses, you can only do the minuses. But great question.
When you have something like this and solve, you need to have 3 different answers, yeah?
All right. Now, here, Donald, is where we would have done the m. Right? This is where we would have done the m. So this is the sum of two cubes. So this is going to be 2x plus 3y. Hopefully everybody got that part. I did say hopefully. Didn't say you did. I said hopefully. Now you can do the m. Two x times 2x. 2x times 3y. 3y times 3y. So you'll get 4x squared. So, same, opposite, minus 6xy, plus, always positive. 3y times 3y is 9y squared. We straight on that? Okay. I'll leave that up for you to write it down if you haven't written it down. Okay. This is your final answer. All right, lastly, how do we factor this and solve it? What was the goal when we had problems like this? You got to have it set equal to 0, right? It's got to be set equal to 0. If it's not set equal to 0, we got to do that. And then how do we solve it if it's once it's set equal to 0? We want to factor it. So x and x minus 9 plus 2. Again, be in the habit of checking. Minus 9x plus 2x minus 7x. Be in the habit of checking that. Okay, I see more people who miss it because they don't ever check it.
What happens if you put plus 2 minus 9?
Same thing. Minus 9x plus 2x is minus 7x, yes. Now, once you have it factored, what are you going to do? Set both pieces equal to 0. So you're going to say x minus 9 equals 0. X plus 2 is equal to 0. X equals 9. X equals negative 2. Okay.
I saw in the book they have the answer in the little package. You have to put in the answer.
So the answer in the book would be in solution set. Negative 2, 9. That's fine. If you didn't, I'd still give you credit. I don't care. Negative 2 and 9.